go through another example. Question 5. A pump supplies 4 kilowatts of energy to the water flowing through a 45mm hose. Now the water flows now 15 metres vertically and through a 25mm branch at a rate of 500 litres a minute. Use Bernoulli's theorem and find the pressure at the branch. So that's the question. What's the first thing you do when working out any Bernoulli's question? First of all, you do your sketch. Do your sketch as you show here. You've got your fire engine, you've got your guy on the branch. As you can see, you've put your Q in, you've put your water power in, you've put your diameter at the bottom. Where are you going to put your datum line? Your datum line, which is the point you're taking all the calculations from, it's got to be level. Your datum's always got to be flat. It can't be up because they've got potential. Always flat. You take it at the lowest point of the system, which is at point A. That's your datum line. You've put in your height of the guy on the branch, which is 15 metres, and you put your diameter. So you diagrammatically draw the problem. Now, what's the first thing we're going to do now? Well, we need to work out, for example, first of all, the pressure at the outlet. Now, this is where you have to bring in another hydraulic formula, which you should be aware of, which is this one here. The water power equals 100 LP divided by 60. So WP is the water power, L is the flow in litres a minute, and P is the pressure. Now, we need to work out the pressure at the outlet. Now, using this formula, WP equals 100 LP divided by 60, we need to get P to be the actual point of the whole equation. So you need to transpose it. Well, how do you transpose it? Well, you need to get everything attached to that P to the other side. Well, how do you do that? Well, at the moment, the whole thing on the right-hand side is divided by 60. So if you times both sides by 60, you get this. WP times 60 equals 100 LP. Well, now, how do you get rid of the 100L on one side to get on the other side? Well, it's 100 times L times the pressure. So all you do is divide both sides by 100L, take that across. Therefore, P equals 60 times WP divided by 100 times L. So you transpose it. So then you put your numbers in. You've got P equals 60 times 4,000. Don't forget it's in watts, 4,000, divided by 100. And L is litres a minute. So it's 500, so 100 times 500. P comes out at 4.8 bar. So you've got the pressure at the outlet. Now we've worked out the pressure at the outlet, we need to convert the units correctly into the SI unit. And at the moment, the flow is in litres a minute. We need to convert it into metres cubed per second. Well, how do you do that? Well, you divide it by 1,000 to give it metres cubed, and then you divide it by another 60 to give it a second. So 500 divided by 1,000 and then divided by another 60 comes out at Q equals 0.00833 metres cubed per second. So there we've got the Q, we've got the flow. So now what do we need to work out? Well, let's work out the velocity at point A and point B. So we know the Q, we know the area, we can work out the velocity. Do you see, you need to work out the velocity using the continuity equation, which is Q equals V. You need to work out the velocity to work out the velocity energy. So let's first of all, let's work it out. Now, let's work out the area at point A. Using 0.7854 d squared. Well, that gives you 0.7854 times 0.045 times 0.045, which gives you 0.00159. So that's the area at point A. And the area at point B, which is at the nozzle, using 0.7854 times d squared, gives you 0.7854 times 0.025 times 0.025 equals 0.0004908 metres squared. So do you understand? You've got the area at the outlet, you've got the area at the branch. We know the Q, so you can work out the velocity using VA equals Q divided by AA and VB equals Q divided by AB. So the velocity at A equals 0.00833 divided by 0.00159 gives you the velocity of the water at A is 5.24 metres per second. And the velocity at B is 0.00833 divided by now the new area, which is 0.0004908, which gives you 16.97 metres a second. So the velocity there is a lot higher. So you've got the velocity at A and you've got the velocity at B. You needed them to be able to work out the velocity energy, because that's all we're trying to work out now. Now we need to work out the energies. You've worked out the units, you need to work out the energies. So you've got to substitute all known values in the correct Bernoulli's theorem. Now this question quotes the pressure in bar. Now don't forget, if it's in bar, you use this formula, Bernoulli's. PA times 100,000, so don't for 100,000, the 100,000 times the pressure energy, plus rho GHA plus half rho VA squared equals PB times 100,000. Don't forget, because it would be pascals if not. That's why it's in bar, times 100,000 plus rho GHB plus half rho VB squared. Let's substitute all known values into the equation. Right, what have we got? Well, first of all, we know the pressure at 4.8 bar at the outlet. So it's 4.8 times 100,000 plus, what's the potential energy at A? 0. That's the datums taken at the pump. There's no potential energy, so that's 0. What's the kinetic energy at the outlet? Well, you've got half times the density of the water is 1,000 times velocity of the water there is 5.25, and don't forget that's going to be squared. And that equals PB, that's the pressure at the branch, point B at the branch, times 100,000, plus the potential energy at the top of the branch, which is 1,000, which is the density, times 9.81, which is G, times 15, because it's 15 metres. You're 15 metres above the pump, it's got potential energy, plus, now we need the velocity energy at the nozzle, half times 1,000 times 16.97 squared. So you've substituted in all known values into the formula. If you multiply these out, you get this. 480,000 plus 13,728.8 equals PB times 100,000 plus 147,150 plus 143,990.45. Do you understand? There's all the energies we know. The only thing we need to know now is the PB. So again, you multiply it out. You multiply these out, you get this. 493,728.8 equals PB times 100,000 plus 291,140.45. How do you get the cross, 291 across, 291,000 across? Well, you delete it. You delete it from the other one. It comes out like this. In the end, it multiplies out to give this. PB times 100,000 equals 202,588.35. Don't forget, all we want is the pressure, PB. Well, at PB, if you divide them by 100,000 each, you get the pressure at the nozzle is 2.02 bar. So at the nozzle, 2.02 bar. That is what it would be. That's how you work this particular, solve this problem out.